Most of today's GenAI systems are architected to run on GPUs. On CPUs and commodity hardware, these systems struggle to perform. With GPU-native architecture, GenAI still remains costly, hard to scale, and inaccessible for the majority of organizations. You can optimize the runtime to squeeze better performance from hardware, but eventually the improvement you get compared to the effort you put in drops off quickly. Post that point, no amount of tuning can fully compensate for an architecture originally designed for GPUs. So we went back to first principles, rethought the fundamentals, and redesigned GenAI systems from the ground up for commodity hardware. To truly democratize GenAI, you have to commoditize it. Commoditization requires a fundamentally new model architecture, one built for CPUs, designed to maximize their strengths and minimize their weaknesses. Our first step in our mission to commoditize GenAI is resource-aware attention, an architecture built from the ground up for CPUs, without sacrificing model accuracy. We started with guardrails as the first application of resource-aware attention, because guardrails are non-negotiable in any serious GenAI deployment. They sit directly on the critical path of every single request. Today, guardrails are costly to operate because they rely on GPU-intensive infrastructure. Try running guardrails on CPUs to save money, and latency explodes. In real-world workloads with around 8,000 input tokens, you'd need 16 parallel workers, resulting in roughly 5 seconds of latency on a CPU versus about 300 milliseconds on a $15,000 GPU. At that point, the guardrail costs as much as the language model itself, and that doesn't scale. To solve this, we built Sentinel, our guardrail system based on resource-aware attention. It delivers state-of-the-art accuracy and can run on CPUs, providing performance superior to GPUs.
We've benchmarked Sentinel against today's leading guardrail systems, including PromptGuard, Protect AI, and others, and it consistently outperforms them across 4 independent evaluations.
And the best part is, Sentinel delivers at just 8.39 milliseconds of latency, including network overhead, running on a standard laptop. In contrast, prominent guardrail systems today take over 18 milliseconds, even when running on a $15,000 GPU server. Which means Sentinel, running on a laptop, is more than twice as fast as competing guardrail systems running on an A100.
When guardrails cost this little, you can deploy them everywhere. They are no longer a cost center. They become core infrastructure.
This is how you democratize state-of-the-art AI. Not by waiting for cheaper hardware, but by redesigning the architecture to work with what already exists.